about the most popular issue right now, especially when the face-to-face distractions return to school. And many students are difficult to answer this question. Our topic for today is all about the problem solving and its strategy. Objective: be able to use problem solving technique to formulate a mathematical model for and solve the complex problem. Second is be able to make appropriate use of technology to solutions of the mathematical problem. And the lastly is to be able to read, comprehend a mathematical argument and identify any flaw in his reasoning. So what we'll do is to provide answer to this student. And I have a guest here, but first of all, are you excited? And I will give to Miss Padillo to continue and giving more thought about this topic. Thank you.
Good day everyone, I am April Joy Padillo and I will discuss the intuition and analogy. Let's proceed to intuition. So what do we mean about intuition? In mathematics, it is the ability that we humans understand something immediately from instinctive feeling rather than conscious listening. And we use our common sense to distinguish some mathematical problem in a good judgment. For example, what would be the product of 417 plus 213 divided by 2? The answer would be around 300 plus. That would be not the exact number, but it is somehow accurate and mostly right, having solved it within a second.
Now we'll proceed to analogy. So analogy is a comparison of two things to show their similarities or relationship. Example, hungry is to eat as thirsty is to drink. Another way of writing an analogy is like this: to separate the sets of words with a colon. Now let's discuss how this becomes an analogy. Let us focus first on first set, hungry is to eat. Hungry is the cause, and if you were hungry, the effect is eat. The other set should also have a cause and effect relationship for this to become an analogy. Thirsty is the cause, drink is the effect. Now that we have both cause and effect relationship on the two sets, then this becomes an analogy. So Mr. Gerald Ganya will be tackling the inductive and deductive.
Leo, for giving us new informations and knowledge about what is intuition. Okay, so now I will discuss what is inductive reasoning and deductive reasoning. First, we have inductive reasoning. It is a reasoning that is based on patterns you observe. For example, Jennifer is always leaves for school at 7 a.m. Therefore, Jennifer is always on time. If you observe a pattern in a sequence, you can use inductive reasoning to decide the next successive terms of the sequence. For example, 3 plus 3 is 6, and 6 plus 3 is 9, and 9 plus 3 is 12, and 12 plus 3 is 15. A conclusion you reach using inductive reasoning is called conjecture. Okay, and next we have deductive reasoning is a logical, non-biased way to solve a problem by testing your hypothesis against given facts to see if it is correct. For example, all birds have feathers. It also refers for the process of concluding that something must be true because it is a special case of general principle that is known to be true. Deductive reasoning is logically valid, and it is the fundamental method in which mathematical facts are shown to be true. That would be all, and now I will give the time to Mr. Harnam. Mr. Harnam.
Thank you, Gerald, for giving us ideas about inductive and deductive reasoning. For some information, let me discuss more with regards to if-then statements and converse. They are for to elaborate more the concept. And what are those? If-then statement and converse. Number 1, conditional. It is statement made by a false statement if hypothesis is true and the conclusion is false. Let's just say and think about if P then Q, where P and Q is a sentence. The statement shows that P is called the hypothetical or hypothesis term and Q is called the conclusion. And then if P and then Q means that Q must be true whenever P is true. And I have an example here. Conditional statement. If today is Wednesday, then yesterday was Tuesday, and the next one is number 2, hypothesis. Hypothesis. What is hypothesis for you guys? Hypothesis, statement that might be true, which might then be tested. Example, Sam has a hypothesis that large dogs are better to catching tennis balls than small dogs. We can test that hypothesis by having hundreds of different sized dogs try to catch tennis balls. How to formulate an effective hypothesis? Number 1, state the problem that you are trying to solve. Make sure that the hypothesis clearly defines the topic and the focus of the experiment. Number 2, try to write the hypothesis as an if-then statement.
And today, we will be talking about a mathematical proofs. So first, what is mathematical proofs? A mathematical proof is an inferential argument for a mathematical statement showing that the stated assumption logically guaranteed the conclusion. Common proofs, the first one is proof by contradiction. A common form of proving a theorem is assuming the theorem is false, and then show that the assumption is false itself and it is therefore a contradiction. The second one is proof by induction. Proof by induction is more advanced method of proving things, and to be honest, something that took me a while. This method is used to show that all elements in infinite set have a certain property. And the third one is the direct proof. In mathematical and logic, a direct proof is a way of showing the truth or falsehood of a given statement by a straightforward combination of established facts, usually assumes existing lemmas and theorems without making any further assumption. As an example of a proof in math. For example, a direct proof can be used to prove that the sum of two even integers is always even. Consider two even integers x and y. Since they are even, they can be written as x is equal to a and y is equal to b respectively. For some integers a and b, then the sum is x plus y is equal to 2a plus 2b is equal to 2a plus b.
And this time I want to tackle the geometric property. Geometric property is a strong form of expansion property in a particular for a sequence of bounded degree finite graph. It is strictly stronger than being an expander in the sense that the trigger constant are bounded below. Okay, so this time we have 7 examples of the geometric properties. First is the reflexive property. The reflexive property of equality states that the number is always equal to itself. Like for example, AB is congruent to AB. Second example is the symmetric property. The symmetric property states that for all real numbers, like for example, x and y, if x equals y, then y is equal x. Definition of congruent segments. Or the congruent segments are simply line segments that are equal in length. Like for example, AB is congruent to CD or AB is equal to CD. Example number 6, the definition of betweenness. Betweenness centrality is measures of centrality in a graph based on the shortest path. And here is the example, or AB plus C or AB plus BC is equal to AC. And example number 7, the definition of midpoint. Midpoint is the middle point of the line segment. It is the equidistant from both endpoints, and it is the centroid both of the segments and of the endpoints. And this is the example. M is the midpoint of A and B. Thank you, Miss Rance. And now we proceed to how to write proof. There are many ways how to write proof. We have we call top-down or inductive reasoning, or bottom-up or deductive reasoning. It is the formal or informal proceedings. For you to able to understand, let's have some examples of direct proofs. So the given is M is the main point of AB, and the proof is AM is congruent to BM. Given that point M is the main point of segment AB. So by definition of main point, the measurement of AM and BM are equal. Since AM is congruent to BM, then by definition of congruent segment, we can say that line is segment AM is congruent to segment BM, or AM is congruent to BM. Alright! Thank you everyone for giving more thought about this topic. And our conclusion is our results are judgment based on reasoning, research, calculator, or etc. The final part of something. And it needs to be proven or established true. And that's all for today. Thank you everyone.